Okay, what's up, people? Happy Easter. A little bit different Easter than what I'm used to experiencing with my change in big life changes. So, not doing Easter like I have done in the past, but we're gonna do some coding, and that is not correct. That is the date, not the time, doofus. So let's go ahead and we'll just say 12 o'clock. It just changed to 12 o'clock, so right on the money here. Last session, what did we do? We did more save logic revisions and code tests in SQLite test part 3. So we're working on this for a while. We've been trying to get that save system nice and tight and beautiful and close to perfect. You'll never have perfect code. It doesn't exist. Reconverted checkpoint ID back to a regular variable passed to stable save state function, since the logic dictates it can't be an adder of the database class. Yeah, that is true. Continued making improvements to code in SQLite test and associated code in save logic. We stopped at line 525 in SQLite test. So let's go there. 525. I don't know how I did that, but okay, here we go. What is... Okay, I thought I deleted code. I thought I was reading wrong. Okay, so 416, that was 4 days ago. I haven't coded in 4 days. Damn. It's crazy. Well, yeah, I worked like a 14-hour shift the other day. I forgot about that. So I couldn't, yeah. Makes sense. And I work late on Saturdays, so I usually don't code on Saturdays. So we stopped there. And I put next. I made changes to this file that need to be reflected in save logic Pi's associated sections concerning garbage collection, adders, etc. Be careful and copy over all changes. Okay, so let's go ahead and do that. Pop me a little gum here. Get that little sugar rush, dude. So, okay, yeah, we added garbage collect, and basically we were having issues, if I remember correctly. We were having issues with the garbage it not being closed out fully. Well, I found out it was best practice to free up my resources and to do garbage collect just in case the resources were not being freed up quick enough to allow for what was it? Like, we're doing a series of commands here, like db stable backup close. We were trying to close, and then we were going to remove, but this accesses the file at the OS level, and for it to be able to do that, the file can't be locked. Well, whenever you are doing SQLite commands, as far as I understand it, the database will actually, the SQLite will lock the file at the OS level, meaning, you know, since they have the lock, you can't actually use OS remove. So I guess in rare cases, if you have the cursor still assigned to this database, even though you have like run this close command, it, according to ChatGPT, I'm not an expert on this, so I don't really know. I just took its word for it. It's usually right that it could still cause issues with the lock. So to avoid that problem altogether, it's suggested to assign the um, database to none after running close. So you run close first, then you set the database to none, because you can't set it to none first because you have to be able to have it assigned to the connection to close the connection. And then after that, you can go ahead and also set the cursor to none as well, and that is gonna remove any reference, you know, to that database connection in memory, so that whenever you had run this close command, this ensures that it is truly closed. That file is free, and then garbage GC collect goes ahead and basically verifies that it is free. And I want to look up just real quick. This is my first time using garbage collect. I'm sort of familiar with the concept, but I've never actually used it. Let's see if this is working. Yep, it's working. I forgot to copy it. Doofus. There we go. Alright, copied, posted. God, that's loud. There it goes. Alright, it's working. That was a little crooked. Alright. So I wanted to look up this garbage collect here to see exactly what it does. And you know, I'm not sure that I like this song. I don't really want it in the playlist anymore. I just don't like it, okay? It's not my vibe, you know? Don't like it. Much better. Alright. So in Python, GC collect is a function from the built-in GC garbage collection module. It forces a garbage collection process to happen immediately rather than waiting for Python's automatic garbage collection to kick in. Triggers a full collection of all generations of garbage. Okay. It returns the number of unreachable objects it found and collected. When you might use it, you're managing a large program with lots of memory use and want more control over when garbage is cleaned up. You're debugging memory leaks and want to see what's being collected. You've just deleted large objects or broken reference cycles and want to reclaim memory immediately. Okay, so it's pretty straightforward. What sort of objects would this clean up? Mainly cleans up objects involved in reference cycles. That is, objects that reference each other in a way that prevents Python's default memory management from cleaning them up. Gotcha. So until the reference counter reaches 0, an object is not cleaned up, as far as I understand that. So a reference cycle. Two objects reference each other. A equals A, B equals A dot other equals B dot other equals A. Okay, gotcha. Even if you delete A and B, they're still referencing each other. So the reference count doesn't drop to 0. Python's reference counting won't catch this, but the garbage collector will. Oh. Okay. Okay. Objects in reference cycles as above. are cleaned up. So if you deleted A and B, but you still have A dot other, this counts in the reference counter like data. And therefore their reference count doesn't drop to 0. So then, like, I guess that means it's still allocating full memory space of A and B. So in the case of deleting A and B, but them still having a ref counter non-zero, does that mean memory still allocates fully to the deleted objects? So objects in reference cycles as above are cleaned up through GC collect. Unreachable containers, like list, dict, sets, classes that contain other unreachable objects. What is an unreachable object? I guess that means something that is like actually deleted but still has a reference counter. I don't know. We're going to find out. Custom classes with dunder delete methods involved in cycles. I don't know what that means. What it does not clean up: objects with live references, objects whose reference count hasn't dropped to 0 and aren't in a cycle, what is a cycle? Didn't it tell me what that was at the beginning? Yeah, reference. Okay, reference cycles are just two objects referencing each other. Gotcha. Okay, so that one it already told me. Objects whose it doesn't clean up objects whose reference count hasn't dropped to 0 and aren't in a cycle. I don't know what that means. What do it mean? What? Huh? Optional debugging uncollectible objects. You can even track what the GC is doing. GC set debug, gc.debug leak, gc collect. This will print out details about objects that couldn't be collected, like objects with del in a cycle. Okay, and then explain memory leaks briefly. So this is usually what I do when I come across a new thing, a new module that like I'm familiar with a little bit. I've heard about it, but I've never really used it personally. I'll take like 10 or 15 minutes to just chat GPT it up and figure out what it does. It usually ends up being pretty beneficial and has been a good practice for me so far. So I continue to do this regularly, and it's just nice to continue to expand your knowledge little by little. It's little bite-sized learning sessions. Okay, so all right, let's break this down clearly and simply. You're asking really great questions. Well, thanks a lot, man, for that motivation. That go right to the core of how Python manages memory. Let's go step by step. If A and B still reference each other, is memory still allocated? Yes, even if you call del A and del B, the memory is still allocated because their reference count don't drop to 0. They're keeping each other alive by mutual references. So I guess that's what a memory leak is. I think. I don't know why it's called a leak. That doesn't really seem like a leak to me, but whatever. Del only deletes the variable reference, not the actual object. If something else, like another object, still refers to it, it won't be freed. Ooh, man. Okay. You know what? This makes me think I should probably use garbage collect, like, probably once per, And then I guess one good thing to ask could GC collect potentially collect data / objects. Let me move my keyboard because it's not in the right spot, obviously, because I'm not typing right. Could GC collect potentially collect data objects that you don't want it to? Like, that could cause a bug. Okay, so I understand this for the most part so far. What is an unreachable object? An unreachable object is an object that can no longer be accessed by your program. I.e., there's no way to get to it from your code, but it still exists in memory. Okay, that's a perfect name. I notice in programming sometimes the name attached to a certain concept or like thing is not, at least to me, a very good choice of like namespace. I'm big on proper, clear verbiage to refer to things. So I like this because unreachable object, that's a perfect way to describe that from what I just read. It's a perfect name for the definition. You know what I mean? An unreachable object is an object that can no longer be accessed by your program. There's no way to get to it from your code, but it still exists in memory because of a reference cycle or some indirect reference. Okay. So we have class A, definite, self-linked, none. A equals A, B equals A link equals B link equals A. But then if you del A, del B, so there's no way to access A.link or B.link. So these are objects because A and B don't exist anymore as variables. But because these two still exist, A-link and B-link, then the memory is still holding on to B and A. So now there's no variable pointing to those objects, but they still exist in memory because they reference each other. It's unreachable but not collected until GC steps in. Example number 3 is custom classes with dunder delete. The dunder delete, I love saying dunder. Dunder delete method is a destructor that runs when an object is about to be destroyed. Okay, so it's just like whenever you, I guess, set something to none or whatever, maybe that inherently calls the dunder delete on it. Oh, that was a banger, dude. Love that one. Ragnarok had some great music, straight up, dude. Just perfect. Matter of fact, okay. We're coding. We're not worried about that. Oh, forgot to set my timer, dude. Why you didn't tell me? Why you didn't tell me, dude? Where are we at? We're 20 minutes in, so that means we gotta go 48 more. Alright. So then we say, dunder delete is also used when releasing a resource. Okay. And then part of a reference cycle. This is a bad case. So we have class node. Node deleted. If two node instances reference each other and have a delete Python's garbage collector might not collect them because it's not sure in which order to destroy them. This is called a finalizer problem. So if you customize the dunder delete instead of leaving it default, it confuses GC collect. because it's not sure in which order to destroy them. Okay, right, because there might be some, like... There might be some... It might need to be done in a certain order, depending on the custom code. So it's basically a safeguard for those instances. Okay, I get that. Objects whose reference count hasn't dropped to 0 and aren't in a cycle. This is kind of confusing to me. These are objects that are still being used or stored somewhere in your code. They're not garbage yet, so Python won't clean them up. That's the normal case for active objects. Objects whose reference count hasn't dropped to 0 and aren't in a cycle. What do you mean aren't in a cycle? They're not garbage collected if they aren't in a cycle, but their reference count hasn't dropped to 0. Yeah, I think that's the part I'm confused about. I don't really understand what they mean by a cycle. What is a memory leak? Briefly, a memory leak happens when your program keeps holding onto memory it no longer needs. In Python, this usually... See, I would refer to this as like memory... Like memory greeting or memory hoarding. I wouldn't call it memory leak. I don't know. There's probably a reason it's called that. Memory leak happens when your program keeps holding on memory no longer needs. Python usually happens because objects reference each other. So that's what a cycle is. Cycle is just when objects reference each other. I'll still ask it just to see if it clarify my mind by giving me a little bit more details. You accidentally keep references in global variables, caches, or containers. You accidentally keep... Wait a second. Am I confused about this? So when you have cache files, isn't that a thing, cache files? So when you have cache files, they can refer to old dead objects, and that will cause the memory to hold onto those objects space. You know what I'm saying? I'm speaking in ghetto chat GPT that it understands me, you know? Blah, 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 blah. And then objects with delete in a cycle aren't collected. Even though Python has garbage collection, you can still leak memory if you're not careful. Okay, so it's referring to leaking memory from the perspective of the larger pool of memory. Okay, so it's a perspective thing. But that still doesn't really do the justice in my opinion. Anyway. Let's see. Want to see a mini memory leak simulation? No thank you. Yes, you're hitting all the right spots. Damn. Me and ChatGPT are making sweet love. These questions show a strong sense for how subtle Python memory issues can be. Let's tackle them one at a time. Could GC collect accidentally collect objects you don't want it to? In most cases, no. It is safe. Python's garbage collector only reclaims unreachable objects, things your program no longer has a path to. But there are rare edge cases where it can trigger unexpected behavior, especially when destructors that are delete are involved. Edge case number 1, Dell's side effects. Depdel self printing maybe writes to disk or updates some state. Okay, yeah. If GC collects run at a time you didn't expect, and this del method does something side effecty, that could cause subtle bugs. Edge case number 2. And this delete method. Well, I thought it wouldn't delete it. I thought it wouldn't work on it. So how could it cause a bug if it doesn't like delete it? At the time you didn't expect, and this del method does something side effecty that could cause subtle bugs. Edge case number 2, weak ref. usage. If you use weak ref to refer to objects that may be collected and you're not ready for them to be gone, you might try to use an object that's already been collected. Okay, so weak ref, don't use weak ref. Simple. What does aren't in a cycle mean? A reference cycle is when objects refer to each other, blah, 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 forming a closed loop. So they never reach a reference count of 0. Both A and B point to each other. If you delete A and B, the reference counts are still 1 because they're keeping each other alive. If they aren't in a cycle, their reference counts drop to 0 naturally. If they aren't in a cycle, their reference counts drop to 0 naturally. And Python's reference counting system cleans them up immediately. But it said if they're not in a cycle and their reference count hasn't dropped to 0, how can you have both of those? That's the last thing I'm going to ask. We went too long. We went too long on this. But I wanted to clarify this because maybe ChatGPT's confused. It might be hallucinating. How can you have who's aren't in a cycle? Example of a cycle, blah, blah. If they aren't in a cycle, okay, yeah, I get that. But that would mean if they aren't in a cycle, the reference count drops to 0. So how can you have an object whose reference count hasn't dropped to 0, but isn't in a cycle? Isn't not being in a cycle the equivalent of having a reference count of 0? You see what I'm saying here? Can caches or containers keep old, dead objects alive? Yes, and this is one of the most common sources of memory leaks in Python. Imagine this. Cache equals blah. Load data. If key is not in a cache, cache key equals big data key. Return cache key. Even if big data isn't used anymore, it stays in memory because it's stored in the cache. If key is not in cache, cache at key equals big data at key. Return cache key. Even if big data isn't used anymore, it stays in memory because it's stored in the cache. It's still referenced, so it's not considered garbage. If you use a regular dictionary or list or set, you're keeping a strong reference. You'd have to use weak value dictionary if you want objects to be collected when they're no longer used elsewhere. Oh, damn. So this is another level of programming that I have not graduated to. Like, so to avoid memory leaks and stuff, that means, because I do this a lot, I mean, I'm sure most people do, most programmers do, you create a dictionary to reference you know, objects in a simple way. So unless you assign those in the context of a weak value dictionary, those objects, even after they're set to none, or, you know, well, yeah, they would have to be set to none, I guess, they would not be collected because they're in that dictionary. So that keeps the reference counter above 0. So you would use from weak ref import weak value dictionary, and then cache equals weak value dictionary. Now objects will automatically disappear from the cache when no one else is using them. Super helpful for memory conscious systems. I mean, look, straight up, my system is not like this. Like, my system is not gonna use all your memory, but this is something that I should probably implement, at least, you know, to just a small degree, to make my brain, like, remember, you know what I mean? So I will go ahead and add this to my things to do. We're gonna put this in non-pressing, and I'm gonna put memory leak fixes. And we're just gonna add the date here. We're gonna say use weak, let's say weak references for certain objects to avoid memory. We'll call it memory hoarding. Well, we'll just say memory leaks, because that's what people say. Weak references for certain objects to avoid memory leaks. And then, i.e., that. From weak ref, import weak value dictionary. Yeah. Okay. Alright, we're gonna move on. We spent too much time on this. Would you like visual? How can you have objects you ever have? Yeah, that'll be our last question. Then we're gonna get to the code, because we've been like prompting for a long time now. What does reference count have? These are normal active objects. ChatGPT is like a black hole. It just kind of sucks you in when you start prompting, and then like before you know it, you're just like. You remember like YouTube in the early 2000s where you would just end up like at 3 a.m. like, where am I? How did I get here? What is the reference count? These are normal active objects. Well, damn. They're still in use and held somewhere in your code. And there's no circular reference involved. Oh, okay. So this is just like if you say x equals 1. Because there's not a cycle. And the reference count is equal to 1. Because you have x equals... Okay, that makes sense. So Python's reference counting keeps them alive, and garbage collection doesn't need to intervene. Garbage collection doesn't need to intervene. Okay. These are just regular objects you're still using. You're gonna have to make me feel so dumb. Okay. Okay, it's too much. Objects in use equals referenced, not collected. Objects in a cycle, possibly not collected unless GC steps in. Unreachable and unreferenced, ready for garbage collection. Baby. Ooh. Okay. And then, okay, so this would be the last one. The last one. So if you had x equals c and then set x equals 0, does that remove c, the c instance from memory, or do you have to explicitly call c delete or something? And I'm pretty sure this is something that happens intrinsically, I would think. These are classes rather than memory management situation. Let's look at this line. X equals C. That creates an instance of class C assigned to the variable X. So now the object has at least one reference from X. Gotcha. So now if you do X equals 0, this returns X to point to the integer. So what happens to the original C instance? What actually happens, X stops pointing to the C instance. If no other reference to that object exists, i.e. nothing else is holding on to it, its reference count drops to 0. Oh, okay. Hit me with that basic logic. Make me feel like an idiot again. Python will immediately deallocate the memory for that object. If the class C has a del method, it will be called right before it gets destroyed. Okay, right. So this is what I was curious about. Does dunder, like dunder delete is what gets called under the hood whenever a reference count of an object drops to 0. And you don't need to call it del manually. It's just like whenever you do 1 plus 1 equals y. Intrinsically, it calls dunder add or whatever, but you don't do that. It's all like under the hood, which is Python is all under the hood because it's in like plain English, and then it gets translated into like a different, like C and shit, whatever. or however it happens. Okay, we're done. That was a good little learning session. Spent a little bit too much time on that, maybe, but it's okay. That was like 30 minutes. So let's go ahead and say 12 to 1234. I feel smarter. I feel like that was worth learning, though. I feel like I have a better understanding of this, of memory management in Python. It's good to know this sort of thing. All right, so then we're going to say learned more about GC and memory management in Python through ChatGPT prompting. Gotta love it. Alright, now we're moving on to the next 1230 phys-iv, and we're going to actually do some code now. Cool, the fun part. So let's go over to SQLite test where we were, and we basically need to... Alright. We need to get this right, because what we're doing here in this file is we have a subset, slightly modified version of the code that's in save logic, and we have made changes to this in SQLite test. So like it's not a one-to-one. We can't use a diff to compare the two. So what we're gonna do is I just want to make sure first of all that this code does work, and that I'm not just assuming that it works. So we have to make sure our database files are deleted first, and I do this manually instead of putting it in the script because I'm just a little lazy, I guess. So there we go. The code runs. It appears to work without any errors, which is cool. And oh yeah, one last little thing is I'm huge on performance. I want to know, because I found out certain things like exec method and the eval method, never to use them because they are so absolutely slow. They're like 1,000 times slower than other workarounds. So it's like just basically don't ever use them, ever. So I want to know, maybe GC collect might be one of those methods that just takes forever. So let's say does gc.collect have a large overhead like exec or eval? Does have overhead, but it's nothing like exec or eval. Totally different beast. Let's compare them. GC collect scans for unreachable reference cycles in memory, traverse object graphs across generations. Okay, I don't know what that is. We're not going to go that deep. Cleans up objects that reference each other but are no longer accessible. Overhead depends on graph size. If your program has created a huge number of objects, millions, that's not us. And many of them are interconnected, then GC collect can take noticeable time. Okay. For small or average programs, it's fast, usually milliseconds or less. So we say start time, GC took, and we could verify this using time it, exec, eval, very different overhead. No, what they do compile and execute arbitrary code. Yeah, I know they're very different. Slower, more dangerous. Summary performance hit mild to medium, high, especially with complex logic. Okay, so let's do just a real quick, just to verify, because ChatGPT has been wrong. It's not infallible. GC collect is fine to use sparingly or during low priority phases at the end of a task or during idle. You probably need to call it manually unless you're managing a tight memory budget, debugging leaks, or dealing with lots of temporary object cycles. One of my But, you know, I found out that this actually wasn't the bug. I thought we needed to add garbage collect to fix the bug, but it wasn't that. I actually just had a very simple syntax error, and it made me, like, think that I needed to do this garbage collecting thing. But, according to ChatGPT, there was still a like, small chance that it could be causing the bug. It could cause an issue with OS remove, so like we added GC collect to remedy that. And if GC collect is that fast, then I would say we should probably use it. But if it's like kind of slow and there might be a better method, like maybe we could check using an if, because an if is super fast. If we just said if like let me write this out. I really didn't want to do this. I really just wanted to go ahead and use GC collect, but I feel like I'm rushing in the sake of wanting to say that I made progress. You know, that feeling of like wanting to feel like you had visible progress. But I think I should probably ask a little bit further into this before I just roll forward with the GC collect. So first of all, just very quickly, we're going to go open up test reminders, and we're going to do what I really don't like doing because I feel like it's a waste of time. We're going to import time it, and then we're going to say time it dot time it, and I hate the syntax of time it. I always forget it. Let's use the most recent because that's probably the... Okay, let's copy this one. Alright, now let's paste that in. And here we go. So we're going to have... we'll just do print. Well, I don't want to do it like that. We'll just say, what are we testing right? GC. We'll say GC time. GC time. So time it, and then we're gonna do enter 1 2 3. Enter. Bam. Then we're gonna put our code in. So we're gonna do import GC. Then we're gonna say, well, it also depends. Like we would have to create some objects first, right, to get an idea. Because if we did GC collect with no objects, let's just see real quick. So we're gonna do GC.collect, and then we're gonna do comma number equals, we'll just say 10,000, and then we're gonna do, stupid scroll wheel on my mouse is totally broken, and look at me. I should just use page up and page down, right? I just forget to use it. It's faster, I think. I don't like how it skips around though. I don't really have good control over it. See, like it went too far. So I kind of regret using it. Number, and then we just say globals, and I would rather do it like this. This makes me remember. And then you say globals, global equals globals. Okay, so there we go. We have import time and import GC. GC time equals time it, triple quotes, code we're running, which is GC collect, triple quotes. Which we don't need triple quotes because like we don't have a series of operations. We just have one operation, which is GC collect, and so this is like good right here. And then we can go ahead and comment this out because we used that reference to get the proper syntax. Now we're gonna go right here and we're gonna run py test reminders. And okay, so it's running. It took a little bit, and I forgot to print it out. So then let's do print GC time. Now let's run it. Whoops. Let's run this again. There we go. And that actually took a pretty long time. That was a lot, even with no objects, because everything is commented out here. So like there shouldn't be. There's nothing not commented out. So unless it's like considering commented out code to be objects, Let me ask this real quick. Would GC consider commented out code as or stored in memory when it runs? Comment out code is completely ignored by GC collected by Python in general. It is never compiled, never turned into objects, and never reaches memory during runtime. It's just a comment. Python, it never becomes bytecode, no object, nothing is allocated. Nothing, so nothing to collect. Gotcha. Okay, cool. That's good. So it's just slow, actually. So GC is really slow. So what doesn't that mean? Let me see something real quick. Okay. Okay. For some reason, I thought that time it gave you the average. I thought it intrinsically did that. I guess I was wrong. So yeah, one iteration is actually very, very fast. It's 0.0. It's a 10th, 100th, 1000th, millionth. So it's 4 milliseconds, right? 4.5 milliseconds. That's pretty fast. Okay. That's pretty fast. And then compare that to, we'll just compare this to an if statement. A very simple, we'll just say, if true. And then we'll say pass. Alright, so whenever you get E, that means it's way, way faster. So actually, let's do 100 to get a... damn, it's still way faster. So damn, it is actually kind of slow. There we go. So 10,000 if true pass is faster, is basically 2 to 2.5 times faster than one GC collect call. So that's actually pretty slow. So GC collect is a little slow, dude. But here's the thing. I think we should add GC collect in the context of the while loop, right? So the main while loop, I think we should probably add that in. I guess it depends on the memory that it's taken up. We can look at the memory that it takes up and, you know, let me see. Also consider using gc.collect once per main while loop, or perhaps once every, well then that would cause computational time using the timer, so like, you know, something like that, or 1x per 100 loops or something, you know, something every now and then to free up the memory to keep it nice and lean. But this is not really required, like, probably for our program, because it's very small. So let's go back to this real quick. Where are we at here? We're at test reminders. Yeah, so it's pretty slow. I'm not gonna lie. So let's see if we can match up. If we do 1,000, that's still E. So let's do 5,000, and let's bump it up to 7,000. Oop, it's almost there. Once you get to 8,000, there we go. Well, actually, I'm an idiot. I was going in the wrong direction. 20,000 would bring us a little closer. 30,000 would bring us... Okay, that's perfectly equivalent. One GC collect call is the equivalent of one if true pass. There you go, boys. This is how you know everything isn't as it seems. That little line right there is the equivalent of 30,000 of these lines, which is bonkers. It's crazy, alright? It's insanity. It's so fast. It's like, man, it's not even... Let's just try to even the playing field here. Let's say x equals 1, and then let's do it like this. We'll do if x equals 1, because this is a little bit more real-time scenario. We'll do return 3, whatever. Now let's run that, and yeah, if x is equal to 1. Oh, dummy. What did I do? Return outside of function. What? Oh, it's not in a... Duh. I'm an idiot. It's not in a function. So we'll just say... How about this? Y equals 3. There you go. This is a little more like realistic. It's even faster. Joking. Oh wait, no. Oh, it's 8 instead of 3. Okay, so it's not faster. So 20,000 of these. Wow. Wow. All right. Well, there it is. Let's do 15,000, and this we gotta get away from this. So if you couldn't tell, I love doing this sort of thing, and it's really a waste of time. It's like looking at grains of sand when you're trying to like build a house. It's just extra. So don't be an idiot like me. Get away from the prompts. Get away from the testing. 12,000. There we go. Okay, so this x equals 1 if x is equal to 1, y equals 3. You can do 12,000 of those for the cost of doing one garbage collect, and that is with 0 objects. Now, let's create for x in range of 1,000. Let's create 1,000 objects. We'll do... Let's create a class called class equals C, and then def init. I'm an idiot, can't type. And then we just say x self dot x equals 1, and there we go. Now for x in range of 1,000, we just create see, I don't know exactly how do you word this. For x in range of 1,000, C. Is that gonna work? I don't know. Honestly, I don't know. Okay, so that does work. does create 1,000 instances of C, even if you don't assign them to variable. It's create 1,000 even if you're not assigning the variable. Here's why. C is called because Python holds temporary reference to that object just long enough to complete the process. It's not stored anywhere, so the reference count immediately drops to 0. So you have 1,000. Okay, so they're just created and then destroyed. Quick way to assign them to variables. You store them in a list. Duh. There we go. I'm an idiot. See? So we would just do comprehension. Objects equals, so list comprehension. Let's see. Object equals list of C for blank in range of 1,000. I gotta get smarter because that's something I should have known how to do. I just... C is not defined. Did you mean C? Yeah, we meant... Oh yeah, you're supposed to name classes capital. So, that's the convention. So, ChatGPT corrected me there and didn't even like tell me, but it's true. Alright, there we go. So now, for whatever reason, let's do objects 2. And we're just going to do it again. Does this actually... It still took the same amount of time. Okay, so now it takes a little bit more. Now it's up to 4-1. And then if we did this again and made objects 3, so you can see that the performance impact of GC collect does go up little by little. Now it's 5-7. Okay, gotcha. This makes sense. Now I can see it scaling up. So if we have no objects, the time is 00035. If we have 1,000, it's 000367. If we have 2,000, it's 00044. And then if we have 3,000 objects, it's 00059. So in reality, we in our project, we probably have about, I don't know, let's just say 200, let's say 300 objects. So for us, it would be probably kind of close to this. I don't know if that's necessarily true. Let's see, if we just have x equals 1, and then, because I feel like doing it on multiple lines seems to have an effect on it. Does that make it go up? Not really. So yeah, I was worried if maybe it's just on a one-liner, it seems to affect the performance differently. I wanted to see if adding multiple lines affected it, and it doesn't really seem to have any effect on it at all. Yeah, it's basically the same. So yeah, this is a good benchmark, I think, to measure the actual real world performance in our game program. And yeah, so you can see it's still very slow. So that was a good little test section, test segment. Let's go ahead and put the proper notes. So we have the date, the title, and then the description. So let's do that here. So date for 2025. Title is going to be GC collect performance is slow. Reminder that GC collect is quite slow. 1x run with 300 objects, 300 simple objects is equal to perf of 12,000 simple if statements. Crazy. So long story short, I have learned that I really don't think I want to use garbage collect, at least not this often. You know, it's pretty fast in the grand scheme of things, like, but those milliseconds and stuff, they do add up. So it can stuff like that really can affect your program's performance, especially if it's being run, you know, a lot. If it's being run 1,000 times within a few seconds, that's 1,000 times multiplier. So if it's a 10th, 100th, 1,000th, or 10th, 100th, 1,000th, yeah, so it's a 10,000th. So if you did 1,000 of them, it would actually be a third, almost a half of a second, which is actually kind of significant. It is. It's not really what you want if you want a really lean, fast program. So what I think we're gonna do is we're gonna try to find an alternate to using GC collect here. So let's go ahead and copy this, and then we're gonna tell ChatGPT our issue here. What we're gonna do, let's go right here, and then we're gonna listen to this banger, another one from Ragnarok. And here's what we're gonna say. We are using GC to ensure that the file is free from locking due to cursor, refs, or dot close not actually being finished. On Windows, it's strict file locking. But since GC is a bit slow, can't we use a simple if check prior to OS remove to have the same effect? And ChatGPT is this smart, it's gonna know just fucking like that, like Genie from Aladdin. Here it is. Yes, you can certainly avoid using GC collect and check if the resources are actually released, like the cursor and database standards for performing OS remove. This approach will give you more control, be faster than enforcing garbage collection, which can be slow, may not be necessary for the kind of cleanup you're doing. Because, like, I'm worried about these two little tiny objects, and what GC collect does is it collects every single object. So it's not like, you know, it's not being called on this. It's like using a backhoe when you should be using tweezers, you know? So here's the core idea. Instead of forcing garbage collector to clean up the cursor and connection, you can check if the cursor and connection are properly closed and cleaned up before proceeding to remove the file. Solution: without GC collect, you can use a simple check to ensure that the connection and cursor are closed. In Python, a closed cursor and connection should release the locks, so we can check their status before removing the file. You can use the following approach: ensure the cursor and connection are closed, and optionally set them to none. Check if the objects are none or closed before removing the file. Here's an updated version of your code, blah, blah, blah. And say close equals none. If DB server is none and DB server backup is none, try and then accept. So we could really just use a try except, right? Because if there is, I think that is the simplest solution right here. And this is why I like consulting ChatGPT. It didn't even give me this as the answer, but just by giving you the conglomerate view of proper Python programming, it basically, you know, it just kind of give me a little idea. And I'm thinking try accept is very fast. I know, I'm fairly certain try accept is fairly quick. So if we were to do like try and then accept, so if we had accept OS error, which that would mean like the file was locked or whatever, we would just try it again, you know? And since this exception is probably rare, but could still happen, it would almost always succeed on the first. So like, we wouldn't even need to add overhead. The overhead would be added on like the back end in the case that, well, I mean, there is overhead to try, but try is like, I want to say try accept. Try accept is almost as fast as if. It's typically quite small, but there knows what difference to be. Statements try accept blocks. Or handle performance consideration in terms of speed are generally faster than try accept because they need to prefer to simple conditions. Be slower when exceptions occur. Python has to handle the exceptions while searching through the exception set, creating an exception object possibly running the code. If no exception occurs, the overhead of try accept is relatively small, but not zero. Python does have to prepare the try accept mechanism, which is a bit slower than simple if. Got you. So, well, then I guess the second question would be, should we use an if statement? Like, if cursor is none and stable backup is none, should we just check that? Could we use equal none instead of dot close? Setting object none calling close database close the method designed to release objects such as behind database network sockets close resource database for any database connection. This without close the connection and cursor may remain open, leading to file locks, especially on Windows or resource leaks. Assigning none just breaks reference to object, meaning it removes variables reference to the object, but does not release the underlying resource. Okay, so you have to use close. If you set an object to none, Python no longer holds reference to it, but the object might still be holding system-level resources until it is explicitly closed. Gotcha. The object could remain in your memory if it has other references elsewhere or be collected by the garbage collector. Ooh. Ooh. It's my jam, dude. But the underlying resources like an open database could not release me. Okay. The object can remain in memory, but the underlying resource will not be released immediately. Just setting it to none here, even though you're setting objects to none. Cleaned it up. Close with none. Okay, let's go close none breaks. Breaks reference does not close it. Okay. Okay. Okay, so we need to call close. Okay, so is there a way to verify if is closed fully before OS remove? Probably fastest would just be try accept, right? I think so, dude. Yes, you're exactly right. I fucking knew it, bro. I already knew it. You know what I'm saying? Duh. I was right. I was wrong once. But I was right about being wrong, so there you go. On platforms like Windows, where file locking is strict, especially with SQLite, even if you close the connection and cursor properly. On platforms like Windows, where file locking is strict, even if you close the connection and cursor properly, there can still be a slight delay before the OS fully releases the file. File locking is strict, even if you close the connection and cursor properly, there can still be a delay before the OS fully releases files. So you use those. It might still fail with a file in use error. The best and fastest way, try accept with OS removed. Yes, wrap in a try accept block is most efficient, Pythonic, and reliable way to handle this. Why didn't you tell me that the first time, dude? Fuck, man. Try and then accept permission error. We'll just do try accept because there could be a variety of errors. Like the one that we typically encounter is actually like an is a SQL light error, and it would catch any of them. So yeah. So we just do accept exception is E. So blah 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 blah. There's a way to check if it is fully closed, kind of, but it's not reliable. You do checking OS access path, but that only tells you if the file is writable, not whether it is locked. Trying to open the file in write mode, which directly tells you if it's still in use, is locked. Return false, not locked, accept permission error, return true, locked. Honestly, if your next move delete the file anyway, then just do try accept. Bam, bam. Okay, problem solved. We're not gonna use GC. We're not gonna use GC, baby. So let's get this shit out of here. All right, get it out of here. Find it and get it out because it's slow. I don't like slow. Alright? I like fast, baby. Lean. Mean. Alright? Movers. Have to close the DB connection, but how? Ensure setting to none, cursor none, and GC collects. Immediately after ensure. Have to close this DB, how do I get it? Yeah, we need to fix that. That's a issue. Alright, GC collect. Get it out of here. Peace. See ya. Where are we at? The rhythm of the night. Oops. Fucking up already. Oh, man. Okay. So what we need to do is we need to do OS remove. We need to add try accept. Add try accept prior to every OS remove. And while can't type at all. And while loop to ensure file is actually not locked prior to OS access. Oh shit. Oh shit. Oh shit. Mexican food. That's making me think of Mexican food. I'm hungry, bro. It's lunchtime. Okay, so add try accept prior to every OS removing while loop to ensure files like that. And we're gonna say probably should put this code in small function, which is called every time instead of repeating code. Yeah. Let's see. In this, we would assign proper vars to equal none. We would run dot close, assign proper vars to none, and the Oxford comma, bitch. Oh, I hate the Oxford comma. It's blasphemous. Get it out of here. In this, we would run close, assign proper vars to equal none, and the last thing we would do is the while loop with try and accept. Accept. Hey. Okay. Alright, so that's where we're gonna stop. Unfortunately, we didn't. I mean, we made that invisible progress. You know what I'm saying? We made that invisible progress. That progress that you don't see, which sucks. I hate that kind of progress. I like to see it. You know what I'm saying? That's why I should be a carpenter instead of a fucking programmer, because, you know. Anyway. So 520. Stop the line 520, baby. Let's go. Let's go. Copy. Go to devlog. Where do we stop? Whoa, we stopped at line number 570. Is it 570? 520, dude. 520. In SQLite test.py. Alright, so this we went to 115. And we continued working in SQLite test.py to solve SQLite errors associated with potential file locking when calling when calling os.remove. Whoops. After .close. This is to ensure file is always not locked. Which causes program crash, exception, or error. Yeah, exception. An error is an exception, right? So your file looks like something like an hour and title today is gonna be this again. More save logic revision code doesn't SQLite 3 part 4. And this one I'll call save logic revision and code says SQLite 4. OS remove file lock issue. There you go. And then we're gonna stage commit and push our changes, dude. So let's go over here and do this 116 to 118. And we're gonna copy this. Now we're gonna do cd out to the root of the project directory. We're gonna get branch, make sure we're on the right branch, which we are. We're gonna do get add, we're gonna do get commit dash m, we're gonna paste, we're gonna enter, we're gonna commit successfully 4 files changed, 44 insertions, 11 deletions. We're gonna get pushed to the upstream. Bam, bam, bam. There it goes. Fucking professional, dude. Told you I got good at this shit. Told you I got good at this shit, bro. Let's back out. Go to the backup. Delete it. Goodbye. Now, bring the new one back in. Check them out. Go to text. Go to devlog. Go all the way to the end. Look at that. 420, baby. 420. I don't fuck with the smoke, though. Okay. Dabs are bad. Okay. Dabs are bad. They make you dumb. I was gonna say they make you sad because it rhymes, but they just make you dumb. Alright, well, that's it. So, moving on. Man, we're getting close, right? We're getting close. Honestly, I didn't want to do what I did today with this invisible progress. I wanted to move on. But at least we actually have like the right solution and not the quick ugly solution. So let's just be thankful we figured out an easy, simple, fast Pythonic way to fix our issue instead of using slow as GC collect. And now we understand memory management and all that stuff a little better, etc., etc. So anyway, have a enjoy the rest of your Easter, and I will most likely see you guys tomorrow. Not gonna code again today, I don't think. So